Hello everyone, let's take a look at question number 18. The question says that there is some change in magnetic flux associated with a coil of resistance 15 ohm. As a result, an induced current is developed in it which varies with time as shown in the graph. The magnitude of the change in flux through the coil in Weber is what has been asked of us. We have been given this graph. The options are 7.5, 4.8, 6.2 and 8.5, and the correct answer is A, 7.5 Weber. Let's quickly take a look at how we arrive at this answer. Now, before I explain what this graph says, to understand what this graph is trying to tell us, we go back and understand what is electromagnetic induction. Basically, they are saying that there is a coil which has a resistance of 15 ohms. That's what has been given to us. Now they are saying that the magnetic flux associated with this coil is changing. That means that somehow this coil is coming in contact with a change in flux, and that could be maybe because this coil is going into a space which has magnetic field. So you can see that in this case, it is moving into a space which has more magnetic field as compared to one which doesn't, and this movement is causing a change in flux associated with this coil. Now this change in flux associated with this coil is going to induce what is known as a current through this coil, and this induced current is exactly what they are talking about. And what is this phenomenon? It is nothing but electromagnetic induction. That's what you have to recognize. Basically, whenever the magnetic flux associated with any coil, any loop is changing, it means it will induce a current, and that is nothing but electromagnetic induction. It is a phenomenon in which the EMF is induced in a coil when magnetic flux linked with it changes. So in our situation now, the magnetic flux linked with our coil changed, and this induced a current through the coil. This is electromagnetic induction. Now this current is changing with time, and they have plotted this current changing with time in the graph that has been given to us. And we are going to use this graph to solve the sum. Now the first thing you must do is to recognize that the induced EMF is given by the formula minus d phi by dt, where phi is nothing but the flux, and therefore d phi by dt means change in flux, that is changing flux with time, and minus because we know EMF is always opposite to the cause which causes it, and therefore this is nothing but Lenz's law of electromagnetic induction. So recalling Lenz's law, I have E is equal to minus d phi by dt. But I also have Ohm's law, which basically says that any voltage can be written as a multiplication of current and resistance. So I can write E, which is my induced EMF, as I into R, where I is nothing but the induced current and R is the resistance of the coil. Now I can see that equation 1 and 2 both are talking about expressions of E, and therefore I can equate 1 and 2. So I have minus d phi by dt equal to IR. And now I have this formula, that is minus d phi by dt is equal to IR. Once I have that, I can write down the formula for induced current. I is equal to minus d phi upon R dt. Now once I have this formula for induced current, the next thing to think about is what it has been asked. What has been asked is to find the change in flux. That is, I need to find what is d phi, that is the change in flux. Now to do that, I have to use this graph. Now what can I use about this graph? To see that, I'm going to rewrite this formula. I'm going to take dt to the other side, and therefore I get I dt is equal to minus d phi by R. But what exactly is this I dt? I dt is nothing but the area under the graph. Now remember, whenever you want to find the product of two quantities which are on the y and x axis of any graph, if you want to find the product, it will be given by the area under the graph. So now you can see that I dt is going to be given by the area under the graph where we have current versus time. Now once you recognize that I dt is given by the area under the graph, the rest is simple. What you have is a formula that says minus d phi by R is equal to area under graph. From this I can say that minus d phi is equal to R into area under graph. R is known to us. R is 15 ohm, which I will put in the formula. Area under the graph is nothing but the area of that shape, that is a triangle, and area of a triangle is nothing but half into base into height. Now we have been told that the height is 5, as you can see from the figure, and the base is 0.2, and therefore I have area under the graph as half into 5 into 0.2 multiplied by the resistance, which was 15. This gives me the answer, that is the change in flux is 7.5 Weber. Don't worry about the minus sign. The minus sign is always going to be present because Lenz's law tells us that the EMF is always opposite to the cause, and therefore I have a minus sign. The point is, the change in flux turns out to be 7.5 Weber, and that is the answer. That is the magnitude of change in flux through the coil is 7.5 Weber. Keep in mind the question asked what is the magnitude. If it was just asked what is the change in flux, you must write the minus sign. So I hope you have understood the explanation for this sum. Thank you for watching.